To me, all of you read my voice on screen. Those are attending in online, guys. Guys, please confirm to me. All of you get my voice on screen. Those are attending in online, guys. Please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please confirm to me. All of you are getting my voice on screen. Am I audible? Yeah, thank you. All right. Good afternoon, guys. And check it what we completed in the last session. I think in the introduction topic we started yesterday. Just yesterday we completed the total like Java history. What is the background story for Java programming language? That part we understood in the last session. Right, sir. Then in the last class, what exactly the content I've given, just I'll give just 2 minutes rewind of the total content. Then after that, all right, before that, I'm asking to all of you, all right, try to take this URL, all of you, to access the classroom notes daily. All right, daily, I'm going to type the classroom notes in the classroom there. Then if you want to watch or if you want to see the classroom document, just try to take this URL. Through this URL, you are able to get the content. All right, all of you are having this URL. All right, nice. Next one is in the introduction part, what we have seen the content. If you have to this overall in introduction, Java history is one topic. Just it is for the sake of knowledge purpose only, not for the sake of any technical view, or not important in the point of interviews and the point of project development. Also, just information only. Next, differences between Java and others that we have to understand today. Next one is after that Java features, Java naming conventions, Java programming format. In Java history, what content I discussed there mainly, if you observe this, right? Java preparation was started in 1991, right, with a team of 30 members led by James Gosling and Patrick Norton, and they started a project named as Green Project at Sun Microsystems. All right, so they want to see mainly three features on their new programming language. First one is simple programming language, tight coded and architectural neutral. Simple programming language in the sense they want to see like is less execution time, less memory, less power consumption. Next, tight coded in the sense less number of intersections and implementing more. And then after this, like architectural neutral, should not depending on a particular operating system, not depending on any particular hardware system. It must be available to every operating system and every hardware system. Right, sir. Now these are the three features they want to see on the new programming language. Then after that, they completed preparing new programming language at the end of 1992. At the end of 1992, they want to give a name. Initially, James Gosling has proposed a particular name to the Sun Microsystems, that means to the new programming language. He sent that proposal to Sun Microsystems. The name is Work. Sun Microsystems has rejected that. Why? Because it is already existed programming language name, so not possible to give this name to the new programming language. Then after that, again they are searching for new name. All Sun engineers are are used to take one brand labeled coffee at their cafeteria. The name of that coffee is what their Java. So they are giving this proposal to Sun Microsystems, and Sun Microsystems has accepted this proposal. And finally, the name for programming language is what their Java. Then after that, they prepared first product on the base of the Java, that is Star 7. It's totally a failure product. They have waited nearly 1.5 years of time to find this, but no customer is identified for this product. It is a failure product. In the mid of the 1994, there is an error for internet in outside. Part of it, www is getting very good demand. Part of the www, the key component is what their browser. Then people are thinking about that browsers are having very good demand in outside. In the mid of 1994, Mosaic is a browser, which is only the browser which has very good demand in outside. It was prepared by Mark Anderson is an undergraduate student at Illinois University at Chicago. As part of his project internship, he went to the Netscape Communications. There he completed project work. As part of it, he completed that browser preparation. To prepare that browser, he took nearly $6.25 per hour. So like this, he prepared. Finally, he prepared like what the total, the total environment there, the total browser he prepared. That browser is getting very good demand. By taking inspiration from this browser, Sun Microsystems wants to prepare a new browser by using Java programming language. That was taken by Jonathan Payne and Patrick Nathan. Two members have taken that. Jonathan Payne and Patrick Nathan. Two members have taken responsibility to prepare that browser. They have taken again 1.5 years of time to complete that browser. At the end of 1995, they completed preparing this browser. So at the end of 1995, they give a name for this browser is what their hard Java browser. Because of this reason, people are misunderstanding that Java was released in 1995. Okay, fine. Hard Java browser was released at the end of 1995. All right. When number of requests are coming from outside to Sun Microsystems about to release Java officially to outside, finally they fix the date for it to release Java versions to the outside market. Then on 1996 January 23rd, they have taken the date to release Java versions there. They have released that first version of the Java on the same date with the name JDK 1.0 version. From that point onwards, every 1.5 year or 2 years of time, a new version was released there. Finally, the major milestones of the Java versions are Java 1.0, JDK 1.0 is a language was introduced. In 1.2, major changes are available. In 1.5, again major changes. In like next one is 1.8 version. After this 1.11 version. After that 1.17 version. Now minor version is going on 19 here. It's not major version here. 11 and 17 are long-term support. They are the major versions. Huge number of changes are available in these milestones only. Maybe in the upcoming versions, maybe we may check what is going to be happen. This is what exactly the content we completed in the last class, last session. Right, sir. All right, sir. Then after this, after completion of this, another thing is like what there. Today here we have to understand the differences between Java and others. Right, sir. Differences between Java and others is the next topic. Right, sir. This is somewhat interesting for us. At the same time, at basic level, we have to understand this topic. Right? You should not neglect this topic there. So many fundamentals I'm going to be covered in this particular discussion here, but we have to understand each and every one. Before this, I want to give clarity. What is the requirement to take this particular topic at present? What is the need of taking this particular topic at present here? If we come for this point, answer is very clear. Try to understand it. What is the requirement to take this one particular one? In outside in general, if we ask to somebody else, tell me if I want to learn Java programming language, what I have to learn before Java? Immediately people are responding to you. If you want to learn Java programming language, first we have to learn C++ programming language. People are used to say that. Okay. And then you're ready to learn C++. When you ask to somebody else, now I want to learn C++ programming language, before this what I have to learn? Again there is a question. Again people are suggested to you, if you want to learn C++, first you have to learn C. So they are framing one chain process. First you have to complete C, next one is a C++, next one is what there? Java. Right, sir. This chain process people are discussing, people are giving actually, got it or not? But it is not true. This is totally wrong interpretation. It's a wrong analysis. Clearly I'm telling them. To learn a Java programming language, no need to have any prerequisite courses. Clearly I'm telling them. Not required to have any awareness on C programming language and C++. Directly we can start core Java. Think a minute about it. Core Java is a fundamental course or not? C is also a fundamental course or not? C++ is also a fundamental course or not? So for learning fundamental course, for learning one fundamental course, how can you make another course is another fundamental? No, not at all required. In which way we are trying to understand C programming language, in the same way, come to Java and try to understand. You will understand everything. The point is why people are saying this kind of chain process there. People are giving clarity is, if you learn a C programming language, you may have some grip on basic fundamentals of the programming languages. Like what are the basic fundamentals? No, how to write if condition, how to write while loop, how to write for loop, how to use break statement. This kind of fundamentals you may get awareness. On the basis of that awareness, if you come to Java, then Java is very easy. But the problem is what? But the point is what? In a C programming language, what you want to learn basics, all these basics are available inside the Java again. For learning for loop and while loop and all these things, no need to go for the C programming language. The same things are available inside what there Java. In Java also, all the concepts are available. Got my point or not? So because of that reason, I'm telling there clearly. I'm telling there to learn core Java, no need to have any prerequisite. No need to attend for any prerequisite content. Especially in my classes, what I'm telling to you, if I need any prerequisite topic for Java, for learning Java, if I need any prerequisite topic, I will discuss that prerequisite, then I'll come back to the Java. Don't worry for it. But my main intention is what there? To learn Java, not required to go for any prerequisite content. Just come to the classes with a fresh mind, that's sufficient. Answer my point here. To say this particular point only, I'm taking this particular topic like what are the differences between Java and others like C and C++. No need to learn C and C++. I want to show Java is totally different programming language when compared with C and C++. So not required to learn. That is the reason why I'm going to take this particular topic. Here itself I'm telling there other programming languages are what there C and C++. Alright, sir. This is one point. Second reason I'm telling you why I'm taking this particular topic at present at very startup mode. For example, if you have any opportunity to attend for some interviews in a company, or if you're attending any interviews in outside, if you have any opportunity to attend for interviews in outside, then in general, we may prepare our resume. In that resume, we may specify some skill set or a technology, some field is available. There we are going to specify what? Your technologies list we are going to specify. In general, while preparing resume, we thought of it, all these technologies names we know, so that we are going to keep all the technologies names like C, C++, core Java, advanced Java, Hibernate, Spring Boot, microservice, web services. The total list we are able to say. Just if you know name of the technology that you used to say in that resume. That's a bad habit actually. No, while preparing your resume, what you know, then specify up to that. Don't provide unnecessary things. Point I'm telling there. What is the meaning of it? We are giving resume to the interviewer in the sense, what is the meaning of it? No, we are giving some information about you to the interviewer. So once you specify something in that resume, interviewer will have right to ask anything on that particular view. Whatever the technologies you specified inside the resume, if interviewer is identified the technology in that resume, then indirectly we are saying to that interviewer, you are perfect in that particular technology. So interviewer is having the rights to ask any type of question on this particular area. So that's why while specifying these technologies inside our resume or skill set in our resume, first think about it and think about that skill set. Clearly understand that skill set. Got my point or not? So whether you really know the technology or not, identify it. If you know the technology really, specify that one. Otherwise, don't specify the technology. You know only C programming language. Feel happy for it and specify only C. If interview is required, then he will take interview. Otherwise, he will not. He will say that I require more than this, like this. Understand my point again? But without knowing the technology, if you provide like what they, if you specify some Java, Hibernate if you specify, or Spring if you specify, interviewer may ask questions on Spring. If he's asking questions on Spring, where we are going to give answers for it, how we are able to give answers for it, right? So that's the first thing here. What I'm telling there. Then while preparing your resume, really what you know about these technologies, that specify up to the technologies only. Don't provide unnecessary technologies, right, sir? But in general, our habituation is what there. We are going to specify C, C++, Java. This is minimum common. Then there is a chance for that interviewer to ask a question to you. What is that question there? C, C++, Java you specified there in your resume. Tell me differences between C, C++, Java. Definitely, interviewer may touch this question. Tell me the difference between C, C++, Java. Some other interviewers may ask a question to you. Already you have C and C++ in outside as a programming languages. What is the requirement to come for Java? What is the need to come for Java? Why we are selecting Java now over C and C++? What do you know something about Java over C and C++? When interviewer is asking this question, at least we have to open our mouth. There we have to give at least some answers. Understand it clearly. So that's why here I want to take this particular concept now. At least we have to open our mouth and at least we have to give 5 or 6 number of points minimum. They shows clear cut differences between Java and others. Up to that we have to understand clearly. Even to learn these concepts also, no need to have any prerequisite. Right from scratch, right from zero level onwards, I'm going to talk about these concepts here. So just we have to understand the points what I'm going to say now. That's it. Again and again I'm telling there. No need to have any other thinkings in our mind. Just come to the class with open mind, just with a free mind. Easily we are able to understand every point here. Right, so now let's come for the point here. I want to start that very first one. Very first difference between C, C++ and Java. I'm telling there, observe carefully. The very first one is what there. C and C++ are static programming languages. Come again. C and C++ are what there? Static programming languages, but Java is a dynamic programming language. Java is what there? Is a dynamic programming language. That's it. Now this is the very first point I given there. First one is what there? C and C++ are static programming languages, but Java is what there? A dynamic programming language. First of all, understand it. What is static programming language and what is dynamic programming language? First understand this. After that, we will think how C and C++ are static and how Java is a dynamic. Later on, we will think about it. But first, we have to understand when a programming language is static programming language and when a programming language is a dynamic programming language. I want to give clarity on this. All right, sir. All of you observe carefully what I'm trying to say now. All right. Before going to understand this, I'd like to give some small diagrammatic representation. Try to follow this. After that, we are able to understand this point automatically. See this point here. For example, I have written a C file, a C program I have written. That C program we have written in the sense, file name is what there, some name .c, extension must be .c. That is a C program. Anyway, whatever it may be, maybe C or C++ Java, whatever it may be, one program I have written. Example I have taken C. Inside this, I have written some code. Inside this, I have written what there, some code. Guys, observe carefully. This code we have written in a developer understandable language or not? Come on. .c file I have written where developer understandable representation is provided or not? Int I is equal to 10 is a developer friendly in a section, developer understandable in a section. For loop, developer understandable in a section. That means developer is able to write C program in his understandable representation. The developer understandable representation is called as high level language representation. The C program, whatever the C program we have written, that is high level program where developer can understand the program. Clear. Next one is, what is the purpose of writing this C program? For executing this program to get some output or not? The main intention of writing this program is what there? We have to execute that program, then we have to get output or not? Right. For that purpose, then what I am telling there, to execute our program, here I'm going to take an engine, a separate engine I want to take to execute our program. To execute our program, we are going to take a separate engine. That engine is what there, C engine. Again, I'm telling you, try to remember these points now. To execute the C program, we will use a separate mission. That mission is C engine. To execute C++ program, we need another mission. That is what the C++ engine. Similarly, to execute Java program, we are going to use a separate engine, Java engine. The Java engine is also be called as JVM. What's that? Java Virtual Machine. Similarly, to execute Python programs, we are going to use a separate engine. That engine is PVM. PVM. Python Virtual Machine. Java Virtual Machine. Remember this. Right, sir. Now here we are using what there? C engine. Right. Now tell me, C engine is what? Now here, high level representation. Now C engine is what? The C engine is able to understand only low level language representations. C engine is what there is a mission basically. C engine is what there is a mission basically. It required low level representations. Understand it clearly what I am telling there. High level representation is what there int I is equal to 10. Low level representation is what there we can understand. This is low level representation. Binary representation. Got it or not? Alright, sir. Okay. Now here I've written my C program. I must give the C program to like what there to the C engine. I must give the C program to what there C engine. C engine has to execute this program and it has to generate some outputs. C engine has to execute my program and it has to generate some outputs. Some results we are able to get, some output here we are going to get. This is what we are expecting now. Okay, but observe carefully. Developer has written the C program in high level, but the C engine required the program in what level? Low level. So where some mismatch is available or not? Come on guys, where some mismatch is identified or not? Because of this mismatch, our program is not executing now. Because of this mismatch, our program is not executing. But I want to execute my program. Why? Because developer knows only high level representation. Developer don't know anything about binary. That means low level representation. C engine knows about only low level representation. C engine doesn't aware about what there that high level representation. Got it or not? All right. But now here what I required here, I need to execute my program. But both are at two different poles. Both are not understanding their opposite languages now. Both are not understanding their opposite representations there, but they want to execute our program. But we want to execute our program. Then what we have to do? Simple example I'm telling there. Try to recognize this. For example, one Tamil person is available from Tamil Nadu, came from Tamil Nadu. One Marathi person is available, came from what their Maharashtra. Both are strong in their local language. They are not aware about a common language. They are not aware about their opposite languages. No. Tamil person knows about only Tamil. And next one is Maharashtra person knows about only Marathi, but they don't know opposite languages. Of course, nowadays might be everybody is able to speak Hindi or English, whatever it may be. Common language is available. That's okay. But example I'm telling you, understand it. So, but both wants to have some conversation. Tamil person is speaking in Tamil, but Marathi person is unable to understand it. Marathi person is speaking in Marathi. Tamil person is unable to understand. That common conversation is not going on. There is a communication gap. That conversation is not going on. Messages are not exchanged. Messages are not transferred properly. So both the persons are not aware about their opposite languages. No, they are unable to understand their conversations properly. So communication is not proper. Right. In that situation, what they have to do? In that situation, what they have to do? They require one middle person or not? Between Tamil Nadu and Maharashtra, what is that middle? Telangana, right? Telugu person is required or not? Just I'm getting there. Not like this. Even Telugu persons are aware about only Telugu only. That's the problem again. Not like this. So definitely we need one translator or not? Between these two persons, one translator is required. What the translator is able to do? Translator can listen Tamil first. It will translate into Marathi, and that information will be passed to Marathi person. Again, Marathi person is speaking like in what they're in Marathi. This person is translator is able to listen that, able to convert from Marathi to and Tamil and giving that information to Tamil. Now finally, because of this translator, the overall conversation is good or not? Overall communication is established properly or not? Same situation is available here. Same situation is available. Developer can write program in high level, but mission required program in what level? Low level. Developer can write program in high level. Developer cannot write program in what their mission language. But mission required program in low level. It unable to understand high level program. So now here we require a translator or not? Right, exactly. Here we are going to provide a separate translator. Instead of saying the translator, I want to say a translation mechanism. There we are going to say what there? A translation mechanism. Now here we want to use one translator here or a translation. Here we want to perform that. Translation. Here we are going to perform. What is the job of this translator? No. This translation process will take C program as an input. It will translate the total C program from high level representation to low level representation. That the translation process is able to translate program from high level representation to low level representation. Observe carefully. These low level representations are provided in the form of a separate file. Low level representations are provided in the form of a separate file. That file is .exe file. When .exe file is provided, which has what their low level representation totally. Right, sir. The total representation is what their low level representation here we can understand. Right, sir. Then after this, low level representations here we are able to get. Right, sir. This low level representation here we are getting there. Right, sir. Whenever we are getting this .exe file, if we give this low level representation to that C engine, now C engine is able to perform execution. Now here C engine is able to perform what their execution. We can observe this clearly. Now execution is going to be performed by C engine. Execution will be performed. Then finally we are able to get what their output. Observe carefully, all of you know. Right, here we have used some translation process or not? Conversion process or not? This conversion process is able to take C program as an input. It is able to convert that C program into what their .exe file. Now the translation mechanism what we have taken to translate our program from high level representation to low level representation. I want to say this is again what their low level representation, low level language representation. So to convert our program from high level representation to low level representation, whatever the translation process here we have used, that translation process is called as compilation. The translation process is called as what there? Compilation. Even though if you don't know anything about programming languages, with my concepts you can understand clearly. I said to you, I want to start right from 0 level. No, now I'm starting -100 level. Almost all I'm giving clarity what is compilation. Shall we hear clearly what is the purpose of compilation? No? To translate our program from high level representation to low level representation. Right, that's perfect. Right, so now here I want to provide what there. Compilation in the sense mainly two things. What are the two things for compilation? No? One is to translate program from high level representation to translate program from high level representation to low level representation. To translate program from high level representation to low level representation. This is point number one. Another point I'm asking there. Now try to understand it. Myself, I'm preparing Java applications nowadays. Might be in my classes now. How I'm preparing my Java projects now. I may not take even a second attempt. And first attempt itself, I'm able to get outputs. Now I'm able to execute the programs in this way. And first attempt, directly preparing program and executing them. Finish. Output we are able to get. Why? Because why I'm getting outputs on the first attempt? No, I had very good practice. Batches by batches. I had very good practice over there. That's why I'm getting outputs now. You might be thought about it. Why myself I'm getting outputs on immediately, but why you are not getting outputs immediately? May have this kind of thought. But the point is what you are not recognized it. On my first program execution, I might be taken 30 to 40 attempts now. To complete my first application, I've taken 30 to 40 attempts. Clear? This is common for everybody. Even though James Gosling is preparing Java program first time, he might be taken few attempts to complete the first program. Understand it now? So what is the point I'm telling there? Who is writing our Java programs actually? Java or C or C++, whatever it may be. Who has written that program? Developer or not? Developer is writing program. Programmer is writing program. Who is that programmer? Is a human being or not? Come on, guys. Programmer is human being or not? Very clear. What is the fundamental right for human being? What is the fundamental right for human being? Taking food and sleeping, no? Tell me, guys, what is the fundamental right for human being? Committing mistakes is the fundamental right. Definitely. Having mistakes is the first option for the human being. Everybody will have mistakes now. If you are not having mistakes throughout your life, you are not a human being. You are a god or maybe ghost. Either of the things. Got it or not? But everybody will have mistakes, definitely. But the point is what? While writing the program, definitely developers may have some mistakes. Having mistake is not a crime. But without verifying our program, whether my program contains mistakes or not, without verifying my program, trying to execute the program is a big crime. Get my point or not? Without verifying your program, whether that program contains mistakes or not, without verifying that, trying to execute the program is a big crime. So what I'm telling there clearly, before going to execute our program, you must check whether our program contains errors or not. Whether you read that program as per Java rules and regulations or not. Whether you prepared our program is as per Java rules and regulations or not. We have to check it. Maybe some violations may be available. Some rules and regulations may be violated. Right. Whenever we violated these rules and regulations, no, there definitely some problems here we are able to get. With that problems, we are unable to execute the program. So when problem is identified, go to program, again try to verify that program, try to correct that problem, whatever the problem you got it. That kind of checking process is required. So the process of checking whether mistakes are available or not in our Java program, in our C program, the process of checking whether our program contains any error or not, that is called as error checking. That process is called as what? Error checking. All right. Who is going to check that errors actually? Who is having that capability? No. Same compilation process is able to perform error checking just before translating our code from high level to low level. Before translating our code from high level to low level, our compilation process will check our developers committed mistakes. Developers mistakes are identified, are checked by compilation process. Now the second the second thing is what there, to check the developers mistakes in applications or in programs. That is another reason for what their compilation. Right, sir. Now I'm asking one question to all of you. Now try to answer for it. What is the purpose of compilation? All of you now tell me two reasons. What are the two reasons? No. First one is what there, to translate program from high level representation to low level representation. Second one is what there, to check the developers mistakes in programs. Tell me in which sequence it is going to be happen. First error checking will be performed. After that only translation will be performed. Without checking error, it will not perform translation. Once it is translated, in the sense, no errors are identified. If any error is identified, again the same program is available as is without translation, but error message will be displayed to the user. User has to recognize that error message. User has to go for program where he has to correct the program. So this is what exactly the meaning of what there, compilation. Good. All of you are getting clarity up to now. All of you are okay up to now. Now let's understand the next few points here. Next two more points. The time when we compile the program, is called compilation time. The time when we compile the program is called as what? Compilation time. All right, sir. The time when we compile the program is called as compilation time. This compilation time is also be called as a static time. Compilation time is also be called as what there? Static time. Similarly, the time when we execute the program, that is called as execution time. The time when we execute the program is called as what? Execution time. The time when we execute the program is also be called as dynamic time and is also be called as runtime. Different terminologies. In the future we may use them. The time when we compile the program is called as what is their static time and a compilation time. The time when we execute the program, runtime, dynamic time, execution time. Clear or not? Please remember this terminology. Next one. Okay, forget this total concept here. Just keep this entire information at one side now. Let's come for one more point here. Are you aware about this statement? Int I is equal to 10 semicolon. What is that statement actually? Declarative statement. I is a variable. Its data type is what there? Int. Got it or not? Okay. Now see this one. On the basis of this int, on the basis of this keyword int, on the basis of this int, internally what happened there? 4 bytes of memory or 2 bytes of memory will be created. For int, 2 bytes of memory will be created. For the variable is what there? I. Then where the 10 value will be stored inside this memory. That's clear. All of you are getting clarity on the basis of the int. Okay, 2 bytes of memory will be created. That memory is marked with I variable. That is a variable where the 10 value will be stored there. This is going to be happen. That means my point is what? Similar to int, byte, short, int, long, float, double, boolean, character. So many data types are available. All these data types are what? They're primitive data types. Come again. All these data types are what? They're primitive data types. What are the primitive data types? No, byte, short, int, long, float, double, boolean, character. Like these primitive data types are available. Depending on language, some of them are available, some of them are not available. But int, float, long, like double, then what next one here? Float, okay. Then character, boolean. These are common. Byte, short, available or not available, that depends on the programming languages. But mainly these primitive data types are available. Observe carefully. For these primitive data types, memory must be allocated or not? For integer, how many bytes of memory? 2 bytes of memory is allocated or not? Similarly, for character, 1 byte of memory. For boolean, 1 bit. Like this, for the primitive data types, some memory will be allocated or not? Come on, guys. Right. Observe carefully. Observe carefully. If the memory allocation is provided at compilation time, if the memory allocation is provided for the primitive data types at a compilation time, then that memory allocation is called as static memory allocation. What's the point I'm telling there? If the memory allocation is going on for the primitive data types at compilation time, that memory allocation is called as what there? Static memory allocation. If the compiler is providing memory allocation for the primitive data types, then that memory allocation is what there? Static memory allocation. Similarly, if the memory allocation is provided for the primitive data at a runtime, at a dynamic time, if the memory allocation is going on at runtime, at a dynamic time, then that memory allocation is called as what there? Dynamic memory allocation. That memory allocation is what there? Dynamic memory allocation. Static memory allocation, and second one is what there? Dynamic memory allocation. Yes, sir. Are you getting it or not? Static memory allocation, and second one is what there? Dynamic memory allocation. Right, sir? My total movie is completed. Now I want to go for conclusion. What is the conclusion? No, listen carefully. If any programming language is following static memory allocation, if any programming language is following static memory allocation, then that programming language is static programming language. Got my point? No? If any programming language is following static memory allocation, then that programming language is what there? Static programming language. If any programming language is following dynamic memory allocation, then that programming language is called as what? Dynamic programming language. Why I'm discussing all these points? No, actually my point is what there? What is my actual point here? Now please recognize this. C and C++ are what? Static programming languages, but Java is what? Dynamic programming language. This is my actual point. I get my point or not? This is my actual point. Understand it now? So my point is like what I'm telling there. If any programming language allows, if any programming language allows static memory allocation, that is the memory allocation, that is the memory allocation is provided for the primitive data at the compilation time, then that programming language is called, static programming language. That programming language is called static programming language. This is the definition here, what I've given there, static programming language. Examples I'm telling there, observe carefully. Examples, C and C++. Examples are what there? C and C++. All right, sir. Then how can we say this C and C++? No, the point is very much clear. In the C and C++ applications, C and C++ applications, memory will be allocated for the primitive data types at the compilation time only, not at execution time. Because of this reason, we can conclude C and C++ are what their static programming languages. Yes, all of you are getting clarity up to now? Yes, sir. No response, guys. All right, that's okay, fine. Now this is about static programming language. Now let's come to the next point. What is this next point here? All of you understand it? Dynamic programming language. I'm telling there. Try to understand it now. If any programming language allows memory allocation, that means dynamic memory allocation. If any programming language allows dynamic memory allocation, that is the memory allocation for the primitive data types at runtime. At what time here? At runtime. Then that programming language is a dynamic programming language. If any programming language allocates memory for the primitive data types at runtime, then that programming language is what their dynamic programming language. All right. Examples for dynamic programming languages are what there. We can observe carefully. All right, sir. Now here, example is what there? Java. Java is the best example. As per our discussion, Java is the point here. That's okay. Of course, Python. In the case of Python, no concept like static memory allocation. Everything is going in at runtime only. Why? Because no separate phase for compilation. Everything is going in at runtime only. So purely dynamic time, runtime in the case of Python. That is not required for us now. Leave this part here. All right. Why? Because in Java applications, observe carefully. Java applications, memory will be allocated for the primitive data types at a runtime only. Memory will be allocated for primitive data types at a runtime only. Not at compilation time. If you want to remember one point, I can give one more point here, but I will not give document now. In the document, I will not give, but for our remembering purpose, I'm telling them. Observe carefully what is the point I'm telling now. How Java is a dynamic programming language. This is another proof here I'm telling to you. Try to understand this clearly. All right, sir. Observe carefully. Everybody, observe carefully. In Java, memory allocation is going in at runtime. We are confirming that. But how it is now, I will give some reason. Try to understand it now. All of you observe carefully. In Java, when memory will be allocated for the primitive data types, actually, memory will be allocated for primitive data types in the form of objects only. That means when object is created, then only memory will be created for primitive data types. Object is what? A memory block. a block of memory, not more than that. Whenever object is created, then only memory will be created for primitive data types. Why? Because Java is an object-oriented programming language. Java is what there? An object-oriented programming language. So in Java, when objects are created, then only memory will be created for primitive data types. But in Java, when objects are created, at what time objects are creating in Java? In Java applications, objects are creating at runtime, not at compilation time. In the case of Java, objects are creating at what time there? Runtime, not at compilation time. So in Java, objects are creating at runtime. So memory is allocating for the primitive data types at what time? Runtime, not at compilation time. So because of that reason, Java is what there? A dynamic programming language. By this also we can conclude Java is what there? A dynamic programming language. That point is clear or not? Alright, so now, whatever the diagram here I prepared, the total diagram I'm giving there, now try to recognize it. Just it's for the sake of your reference, I'm giving this diagram here. We can manage this diagram as per our requirement. Right, sir. That's okay, fine. Then finally here we understood this particular topic. What's the topic here I given there? Totally C and C++ are static programming languages, but Java is what there? A dynamic programming language. Clear. Let's come to the second point. Second difference, no? All of you observe carefully. Preprocessor is required in a C and C++, but preprocessor is not required in Java. Preprocessor is not required in Java. This is the second point here we have to understand. Right, sir. Don't worry. I'll give much clarity on this topic also. Preprocessor is required in a C and C++, but preprocessor is not required in Java. Right, sir. And people are asking to me, give an example with the help of code. Right. This is very, very first class technically. Even without knowing any programming language, how it is possible to write the code. Understand it here. So when I complete first program execution in Java, from that point onwards, coding is going to be happen. So introduction part is totally theoretical concepts. After completion of introduction unit, steps to prepare first Java program. The topic I'm going to start from that point onwards, I'll start programming now. So don't hurry. On the first day, we are not going to learn the complete information here now. Understand it clearly. So I need to recognize everybody. As per that everybody's information only, I have to take the content here. So step by step, I'm planning for this course here. Right. All of a sudden, if I start Java program there, then what will happen? Then nobody will understand the complete information there. That's why then wait for the moment when I'm going to start programming part here. Right. So let's move on to the point here. First of all, here we have to understand only the concept. Why we are coming for Java over C and C++. What is the requirement to come for Java over C and C++? Only that's the point here. Mainly I'm focusing now. There I'm giving some clarity. Now tell me, static programming languages and dynamic programming languages, two are available. Which one is good? Which one is an advantage one for us? No. Which one is providing advantage? No. Definitely dynamic programming languages are more advantage. Dynamic programming languages are more. And nowadays, every programming language is trying to provide in the form of like what they're dynamic programming language only. Nobody is going to introduce static programming languages. Static memory allocation is wasting our memory in some cases, no. But dynamic memory allocation is improving our memory. Example, I'm telling that with or without the requirement, static memory allocation is going to allocate the memory. Whether we are going to use them at runtime or not, we don't know. But at compilation, the memory will be allocated. But in the case of dynamic memory, what happened? As per the requirement only, memory will be allocated. As per the requirement only, memory will be allocated. That advantage we are able to get. So memory we are able to save in the case of what that dynamic memory allocation. Right, so leave this punch here. Let's come to this punch here. Preprocessor is required in C and C++, but preprocessor is not required in Java. That is the first point here. Preprocessor is required in C and C++, but preprocessor is not required in Java. But before that, I want to give clarity. What exactly the meaning of preprocessor? What is the job of the preprocessor? Where it is available in the programming languages, and what is its role in programming languages? These points here we have to understand first. All right, sir. Now I'm giving clarity where this preprocessor is existed. At which location that preprocessor is existed. I want to give some clarity. Now try to understand it now. Right, sir. Let me give some diagram here. All of you observe carefully. I want to give some diagram here. Now try to recognize this. Now, as usual, here what I want to take there. First, I want to take what there some C program. This is my C program. All of you have to carefully. Whenever I want to set the C program, then we have to provide like what there some dot C is like what there some extension here I have taken dot C. Okay, fine. Whenever we have taken the C program, there we have to compile the program or not? There we have to compile the program or not? Now here compilation. Compilation. Here we are performing that. When we compile our C program, then what we have to do there? We are able to get what files there when we compile our C program. There we are able to get some dot exe file here we are able to get or not. Once again, I'm confirming now in the case of C and C++ dot exe files, but when we go with Java dot class file, in the case of Java, after compilation, we are able to get what there dot class file. But in the case of C and C++, what file here we are getting no dot exe file. Observe carefully. Whenever we are getting this dot exe file, then what I shown here we are going to execute our program. Here we are able to execute our program there. Execution is going on. C engine will execute our program. When we execute this program, automatically here we are able to get some outputs. There we are able to get some outputs. There we are getting like what there some output. That's it. So this is overall diagram here. What I provided, what we have seen in the previous case also. This is the overall content here we provided. Good, nice. Observe carefully. Here compilation is a process here we are doing. Am I right or not? What we are doing, compilation. All right. Under this compilation, how many phases are available? If you observe this, multiple phases are available inside the compilation. What are the multiple phases? No. Preprocessor is one of the phase. Next one is compiler is another phase. Assembler is another phase. Loader, link, editor is another phase. Guys, observe carefully. How many phases are available here in a compilation? No. Overall, 4 phases are existed. What are the 4 phases inside the compilation here? First one is like what there? Preprocessor. All right, sir. Instead of taking this, now first one is like what there? Preprocessor. And second one is what there? Compiler. All right, next one is assembler. Then after that, loader, link, editor. All right, they are the 4 phases. No, they are going to be performed one after another, one after another. Everything is going to be performed. This is what exactly the meaning of what their compilation. In general, people are thinking compilation in the sense only compiler can do some work. Compilation in the sense people are thinking there only compiler is able to perform some work, but it is not. Compiler is not only existed here inside the compilation process. No, in the compilation process overall, 4 missions are used. What are the 4 missions which are used in the compilation? No, first one is what their preprocessor. Next one is what their compiler. Then after that, assembler. Next one is what their loader, link, editor. Right or not? My required point is completed. What is the location of the preprocessor I discussed there that I given the location there, but I want to give some extension from this. Now try to understand it now. Of course, in the future I required these points here. That's why I'm giving this total structure. If we observe this compiler, Again, this compiler is divided into number of phases. Almost 6 to 7 number of phases are available inside the compiler. What are the 6 to 7 number of phases? No. First one is lexical analysis phase. Lexical analysis phase. Next one is what there? Syntax analysis phase. Next one is semantic analysis phase. Next one is intermediate code generation. Intermediate code generation. After this intermediate code generation, code optimization. Then after that, at the end, code generation. Overall, how many phases are available here? No. First one is like what there? Lexical analysis phase. Next one is what there? Syntax analysis phase. And a semantic analysis phase. Intermediate code generation. Then after this, code optimization. Then after this, code generation. These many phases are available. All these phases are going to be performed one after another. Observe carefully. Here, this is what the lexical analysis, syntax analysis, and semantic analysis, intermediate code generation, and code optimization. Sir, got it or not? Right. Now, this is overall picture about our compiler and compilation. All right, sir. Finally, I'm asking one question. Now, try to answer for it. What is the location of the preprocessor? Come on, guys. Now, tell me, what is the location of the preprocessor in this overall structure? Location of the preprocessor is a part of the compilation or not? The first phase in the part of the compilation or not? This is exactly the location of the preprocessor. Clear? Fine. Now, let me copy this diagram here anyway. Anyway, later on I need to use this diagram. Anyway, I want to copy this diagram here. All right. First of all, directly here, what point here we are going to understand? Preprocessor is the first phase. Is the first phase in a compilation process. Compilation process. Right. So this is point number one. Preprocessor is the first phase in the compilation process. Or maybe the first mission to perform some activity in a compilation. That's okay, fine. But what it will do, what it is able to perform, what preprocessor is able to perform. All right, if you come for it, I'll give some clarity. Now try to answer for my questions. All of you know. Everybody, observe carefully. In C and C++ applications, or maybe in C and C++ programming languages, the complete predefined library is provided in the form of header files or not? Think about my point. In C and C++, the complete predefined library is provided in the form of what there? Header files. Even if you don't know header files, no problem. Just header file is nothing but one file where some predefined libraries existed, some predefined methods or functions there existed. That's the meaning of header file. Can you tell me what are the examples for these header files? No, number of examples are available. What are the examples for header files here? We can observe carefully. stdio.h, am I right? conio.h, math.h, and so on, so many. But some of them I given examples. Sir, all of you are getting it or not? All right, sir. In C and C++, the complete predefined library was provided in the form of header files. Examples here I have given there. Some stdio.h, conio.h, math.h. Okay. Listen carefully. This total predefined library is available in the form of header files, but I want to use this predefined library in my C program. I want to use predefined library in C program. If you want to use predefined library in C program, first we have to include these header files to our C program or not? First we have to include these header files to our C program or not? All right, then what we have to do to include, or maybe if we want to use a predefined library, if we want to use a predefined library in a C and C++ applications, first we have to include header files into C and C++ applications. If we want to use predefined library in C and C++ applications, first we have to include header files into C and C++ applications. All right, observe carefully. To include header files in C and C++ applications, we have to use hash include statement. Sir, am I right or not? We have to use what statement there? Hash include statement. Come again. What is the point I'm telling there? If we want to include predefined library in our C and C++ programs, first we have to include header files to C and C++ programs. If we want to include header files to C and C++ programs, we have to use what statement there? No, hash include statement that we have to use. All right, examples are what there for this. Examples I'm telling you. Now try to observe carefully these examples. All right, so now hash include stdio.h, hash include conio.h, hash include math.h. Right, sir? This is what exactly the syntaxes we are able to use what their hash include statements. Sorry, even if you don't know C, I'm giving clarity now. Library is available in the form of header files. If you want to use that library, first we have to include hash, that means header files. To include header files, we have to use what statement there? Hash include statement. What is the syntax I'm using now? Hash include stdio.h, hash include conio.h, hash include math.h. All of you are getting clarity up to Right. Next to 5 minutes of time, the topic is very, very important. Put more concentration, everybody. I'm going to give some internal concept. Now try to understand it. Just 5 minutes of time. Put complete attention. Then only we are able to understand it. Okay? Listen carefully. For example, I have written a C program. Inside the C program, I have written hash include statements. Same as it is. These three hash include statements I have written. Clear? I compiled my C program. I compiled what? C program. When we compile the C program, who will take the first action in the compilation process? When I compile my C program, part of the compilation, who will active as the first one? Preprocessor. What preprocessor will do? Observe carefully. What preprocessor will do here? Point is very clear. Observe carefully. I prepared my C program. Inside my C program, I have written all the hash include statements. Then when we compile our C program, preprocessor will come into the picture and preprocessor will perform some actions. What are the actions that preprocessor is doing actually? Point number 1. First, preprocessor will recognize all the hash include statements. Preprocessor will recognize all the hash include statements. Preprocessor will read all the provided header files names. Preprocessor will take all the provided header files names. Preprocessor will go to C software. Already you have installed C software in your system, then only you are able to run C programs. So preprocessor will go inside what there? C software. Inside the C software, preprocessor will check whether all these header files are available or not available inside the C software. Preprocessor will check whether these header files, the specified header files are existed or not existed inside the C software. If any one header file is not available, if at least one header file is not available in the C software, preprocessor will give some error message as a part of the compilation only. Preprocessor will provide its own error message. In the case, if all the header files are available inside the C software, all the provided header files are available inside the C software, immediately what preprocessor will do now? Preprocessor will take all the header files preprocessor will load all the header files provided executable code to the memory. That means preprocessor will load the total predefined library to the memory at the time of compilation only, part of the compilation only. Come again, what is the point I said to you? When I compile my C program, preprocessor will come into the C program. Preprocessor will recognize all the hash include statements. Preprocessor will take all the provided header files. Preprocessor will search for them inside the C software. If they're not available, preprocessor will raise an error. If they're available, preprocessor will take that header files. Preprocessor will load that header files provided predefined library to the memory. At what time? No, compilation time. This entire thing is going on by preprocessor or not? Entire thing is going on with the preprocessor or not? The preprocessor is a part of the compilation or not? So this entire thing is going on part of the compilation or not? Now tell me, at what time predefined library is loaded to the memory? At what time predefined library is loaded to the memory? Part of the compilation or at runtime? Part of the compilation only. At compilation only, this total predefined library is loading to the memory, loaded to the memory. Am I right or not? Loading predefined library to the memory at a compilation time. Loading predefined library to the memory at a compilation time is called as static loading. This type of loading is called as what there? Static loading. Preprocessor is performing static loading or dynamic loading? Static loading. At what time? Compilation time or at runtime? Compilation time. So preprocessor is able to recognize all the hash include statements. Preprocessor is able to identify the specified header files in C software. Preprocessor is able to load all the header files provided predefined library to the memory. This type of loading is called as what there? Static loading. Now coming to the conclusion. Coming to the conclusion. What is my conclusion here? Preprocessor is required in C and C++ applications. Preprocessor is required in C and C++. Why? Because to recognize a hash include statements in order to load the provided header files content to the memory, we need preprocessor in C and C++. To recognize the hash include statements and in order to load specified header files content to the memory, we need what there? Preprocessor. Yes, sir. All of you get my point or not? Tell me, all of you now tell me, what is the requirement of the preprocessor in C and C++ applications? No? What is the requirement of preprocessing C and C++ applications? No? To recognize hash include statements in order to load header files content to the memory. This is mandatory or not? In every C program, hash include yesterday.h is minimum or not? So when we write that one, preprocessor is required to recognize it and to load that yesterday.h to the memory or not? So because of that reason, preprocessor is mandatory or not? Right, so now preprocessor is required in C and C++ applications. Right, so the two more points I want to write here. Now try to recognize it whether my points are right or not. Now try to check this one clearly. All right, sir. Now when we compile C and C++ applications, when we compile C and C++ applications, compiler will perform the following actions. What actions the compiler is able to perform there? All of you observe carefully. Point number one. Right, sir. What is this point number one? Not compiler kernel. Preprocessor will perform the following actions. First one is what there? Preprocessor will recognize all the hash include statements. Second one is what there? Preprocessor will read all the provided header files names. Preprocessor will read all the provided header files names. Next one is preprocessor will check whether all the provided specified header files are existed or not. Preprocessor will check whether all the provided header files are existed or not. Right. If the provided header files are not existed, then preprocessor will raise an error. Preprocessor will raise an error. Next one is what there after this. All right, sir. After this, what's the point I'm telling there? If the required header files are existed in the C and C++ softwares, then preprocessor will load the required header files to the memory. All right, sir. This type of loading predefined library at a compilation time is called static loading. In the future, I will use this conclusion, static loading. That is completed here. Then after this, after completion of this, then what next one here? Static loading is going on. That's okay, fine. This is going on at the time of compilation here. Got it or not? Now here, my point is what? I want to give conclusion. What is the conclusion here? In C and C++ applications, or in C and C++, preprocessor is required. In C and C++, what is required now? Preprocessor is required to recognize hash include statements in order to load header files content to the memory. Because of this reason, this preprocessor is required in a C and C++ application. This is a conclusion here we are getting clearly. Yes, sir. All of you get my point or not? Right. Relate to this, I give you some diagram also there. You can observe this diagram clearly. A diagram also here we provided about this. Okay, fine. Next one is after this diagram. Now coming to the Java. In Java, why preprocessor is not required? Java doesn't require preprocessor, but why preprocessor is not required in the case of Java? This is a question here. So I'll give some points here. Now try to understand it clearly. Simple point. If you want to answer for this question in the case of the Java, first of all, we have to understand a few more points in Java. Observe carefully. In the case of Java, the complete predefined library is provided in the form of classes and interfaces in the packages. Come again, what's the point I'm telling there? In Java, the complete predefined library was provided in the form of classes and interfaces in what their packages. Predefined libraries exist in the form of what their packages. What are the various packages? No, java.io package, java.util package, java.lang package. So many packages are available. In the form of packages only, the predefined libraries existed. Good. In the case of C and C++, in which way header files are available, in the same way, classes and interfaces are available in Java, but inside the packages. To include a header files to the C and C++ program, there we have used hash include statement or not. Similarly, in the case of Java, to include this predefined library, we are going to use import statement. What statement we are going to use? No, import statement, importing packages, including header files, importing packages, including header files in C, C++, importing packages in what there? Java. Okay. For example, import java.io.store, import java.util.store, import java.util sql.store. Like this, so many packages here we are able to write along with our import statement. Is that got or not? All right. Observe carefully what I am telling there. Basic information here now. In the case of Java, when I compile Java program, in the case of Java, when I compile Java program, no preprocessor is available. Only compiler can recognize import statements. Compiler will take package names. Compiler will check whether packages are available or not. If no packages are not available, raise an error. If the packages are available, don't raise an error. At the same time, compiler is not loading any predefined library to the memory. In a Java, compiler responsibility is only checking whether the packages are available or not available. Compiler will not load any package content to the memory. But when we execute the program, who is executing Java programs? No, JVM. When we execute the program, JVM will load the required libraries to the memory. JVM at runtime will load the libraries to the memory. Now tell me, in the case of C and C++, at what time predefined library is loaded to the memory? At a compilation time. That is called as what? Static loading. But in the case of Java, predefined library is loaded to the memory at a runtime, not at compilation time. In the case of Java, predefined library is loaded at what time there? Runtime, not at compilation time. So loading predefined library to the Java program at runtime, loading predefined library to the memory at runtime is called as dynamic loading. Here one conclusion, C++ are following what loading? Static loading. But Java is following what type of loading? Dynamic loading. Yes, sir, all of you get my point or not? So this is what exactly the difference here we can understand clearly. Now coming to the conclusion, what is the conclusion there? In the case of Java, preprocessor is not required. Why? Because in Java, hash include statements are not available. Why? Because in Java, header files are not available. In place of header files, we are having classes and interfaces in packages. In place of hash include statements, import statements are available. In place of preprocessor, compiler and JVM is available. So because of that reason, preprocessor is not required in the case of Java. Yes, sir, all of you get my point or not? All right, sir. Now, almost all time is up now, but the second part of this explanation, like what there, Java, why this hash include, that means why hash include statements are not available in Java, why preprocessor is not required in Java. That concept again I will explain to you on tomorrow. Again, I'm going to explain this total part on tomorrow. Then after that, I'll move forward. But up to know why preprocessor is required in C and C++, we understood clearly. Remaining part is not understandable to you. Don't worry. Tomorrow, I will explain the remaining part of this particular point. Right? Again, I'm telling to you, those required notes of this classes, no? Just use this URL and use this URL. Then we are able to get notes. Everyday notes. Whatever the notes I typed inside the class, we are able to get it. Now try to take this, right? That's all, guys. That's all for today. Then tomorrow, we are going to see the remaining content. Thank you. Thanks a lot. We'll meet on tomorrow. Thank you. Yeah, guys, and video content link our admin people will send to you. And if you have any pay receipts there, then try to send the pay receipts to this number, WhatsApp to this number, guys. Then our admin people will send that videos link and everything to you. Okay, Rajesh, just to this number, WhatsApp your pay receipt. Then we are able to get video support, everything. Okay, right. Then your receipt and everything send to this WhatsApp number. Then they will share that link to you, Google Drive link. Yeah, whole businesses everyday class link videos. Yeah, sure, we'll get it. Thank you. Yeah, thank you. Thanks a lot, guys.